Mm. Hello there. I'll be teaching the numerical analysis methods, and our first lesson will be solving nonlinear equations. As you know, there are different methods to solve nonlinear equations in numerical analysis, but this time I'm going to choose the bisection method. Okay, let me write the title. Okay, so as I told you, we're going to solve nonlinear equations using the bisection method. Before I give you an example, first thing I want to explain the mechanism, the way how we're going to approach the answer. Okay, as you know, we can sketch a nonlinear equation. Let's say that this will be our graph. And you know that once I'm talking about the solutions, I'm talking about this root, that means the x-intercept. So in this x-intercept, look, this graph here, in this part, it's what? It's negative. F of x here is negative, right? And here, f of x or the y is positive. Are you understanding my point? So, since here, down, here it's negative, and in this part it's positive, that means whenever the f of x is changing from negative to positive or from positive to negative, that means we are crossing this point where f of x equal 0. That means the solution or the root. So let's say I got this point and this point. If I got those 2 points, I'm going to try to approach. That means to be a little bit closer and closer, again closer and closer, as much as possible. I'm going to get closer to the root. So sometimes this number is going to be like in decimal places. So most of the times we have to refer, or we have to decide how many decimal places we're going to work on. That means I might be talking about 3 decimal points, 5 decimal places, whatever. It depends on the accuracy that I'm looking for. Okay, this is the mechanism or the method that we're going to use. Now let's go and have an example. Okay, let's say that we're talking about this this nonlinear equation, which is x cubed minus 4x minus 9 equal 0, and I'm looking for 4 decimal places. Okay, 4 decimal places. So once I start, I'll suppose that f of x equal x cubed minus 4x minus 9. So I'll start with f of 0. You know what I mean? Once I'm saying f of 0, that means I'm going to replace, instead of this x, zeros, and see what will be the answer. It will be negative 9. Then go to the next point, f of 1, that means replace, instead of this x, 1, and here 1. I'm not going to be very fast. I'll give you some time to calculate using your calculators, and the answer will be negative 12. Okay, go to the next point, f of 2 equal what? Replace here 2 and here 2. So the answer will be negative 9. Here, why I'm going to the next point? I'm going to the next point again and again because as you see, this is negative. Here I'm having negative. Here I'm having negative. So I'll stop once the sign is changed from negative to positive or from positive to negative. So let's try f of 3. That means replace here 3 and replace here 3. So here you get positive 6. So perfect. Now you can see that the sign is changed from negative to positive. The sign is changed from negative to positive. That means, as I showed you before, once something is changed from negative to positive or from positive, the f of x is changed from positive value to negative value, that means you crossed the root, you crossed the x-axis. That means it's one of the right solutions. Now I can understand here that the number is between 2 and between 3. So here what you're going to do will be let me change the color. Since I'm going to give you simple notes, f of 2 is negative and f of 3 is positive, then the root lies between 2 and 3, between 2 and 3. Since f of this is negative and f of this is positive, that means the y is changed from negative to positive, then the x is between, the x-intercept is between 2 and 3. So the first approximation my first approximation will be to find the average or the midpoint between those 2 points, which is x1. I'll call it first approximation, I'll call it x1 equal 2 plus 3 over 2. I'm trying to find the midpoint between those two numbers, between 2 and 3, which is 2.5. Now I'm going to try this 2.5 here. I'll change the page. So f of 2.5. Let's see what will be f of 2.5. I'll remind you, my equation is x cubed minus 4x minus 9. This is f of x. So here you need to replace, instead of each x 2.5. Okay, so f of 2.5 will be, I'm waiting for you to use your calculators, I'm giving you some time. It is negative 3.375. So here it's negative, you can see that it's negative. So again I will say here, I'll change my color. F of 2.5 is negative and f of 3 is positive, right? Yes. Okay, here a student will come and ask me, why do you compare f of 2.5 with f of 3 instead of f of 2? You know why? Because this is negative. Since this is negative, I have to go to the alternate. That means to the opposite, to the positive. I cannot compare negative with another negative. I'm not supposed to compare this negative sign with another negative sign, because f of 2 was negative. You remember that? Look, f of 2 was negative and f of 2.5 is again negative. So I have to jump to the positive. So once I need to compare those, that means the point is between 2.5 and 3. So since f of 2.5 is negative and f of 3 is positive, then the root lies between 2.5 and 3. So my second approximation will be the midpoint between those 2 points. That means 2.5 plus 3 over 2. I will call the second approximation as x of 2, x sub 2. So the answer will be 2.75. Now I will calculate f of 2.75. f of 2.75, replace here 2.75 instead of each x. Here replace 2.75 and here replace 2.75. It will give you 0.797. Okay, you can see that this number is what? It's positive. This is positive. So since it's positive, you're going to compare it with the negative or the positive. Of course, we're going to compare this positive with the negative. Here, what's the negative? This is negative. This answer is supposed to be compared with this or this. Since this is positive, I'm going to compare it with this negative. So I will say here, since f of 2.75 is positive and f of 2.5 is negative, then the root lies between those 2 points, which is 2.75 and 2.5. So since the point or the root is lying between those 2 points, I'm going to take their midpoint or their average. So I'll say that this is my third approximation. I'll name it x sub 3. X sub 3 will be 2.5 plus 2.75 over 2, which is 2.625. Okay, I'm going to see what will be f of 2.625. Again, I'll remind you that f of x equal x cubed minus 4x minus 9. So please replace this value instead of each x found here. I'm waiting for you to use your calculators. Well, it's negative 1.412. So this value is what? Negative. So this negative value will be compared with the previous positive. So what was the positive number here? You have to choose between this and this. Between this negative and this positive. So I'll take the positive, which is 2.75, and compare it with this negative. So here I'll write my notes. Since f of 2.625 is negative and f of 2.75 is positive, then the root lies between 2.625 and 2.75. Now I will go to my fourth approximation. That means I'll take the average or the midpoint between those two points. I'm going to name my fourth approximation as x sub 4. X sub 4 will be 2.625 plus 2.75 over 2, and the answer is going to be 2.6875. Good. Now here you can see for the first time I'm having four decimal place, 4 digits after the points. Trying to use this highlight. So here you can see 4 digits. Here I'm having 4 decimal places. So I'm going to work starting from this point. I will go to my calculator now and start working with my calculator. F of 2.6875. I'm going to replace it in this equation. Don't forget that we have f of x equal x cubed minus 4x minus 9. Please replace this number in this equation instead of each and every x, and my answer is going to be negative 0. Oh, what's wrong with my pen? Negative 0.3391. Now go for x5. Use your calculators. It will be 2.71875. Now you can work by yourself at home using your calculator to find the x's. I'm going to work till I get a number that's going to be convergence. x6 will be 2.7031, x7 will be 2.7109. As you see, the numbers are getting closer to 0.7. x8 will be 2.707. Go for x9. Use your calculators. 2.705. x10 will be 2.7061. So the number is converging to a specific value that I'm going to find right now. x11 is going to be 2.7066. x12 will be 2.7064. x13 will be 2.7065. x14 will be 2.7065. Great. Of course, I know that the numbers might be here a little bit longer, but I'm only concerned with 4 digits, 4 decimal places. So in these 4 decimal places are the same like these 4 decimal places. So you can stop here and say that this is your final answer. Okay, I hope that you understood the bisection method. See you in the next lesson. Have a nice day.